Alright, so now we need to make a scatter plot of our points that we made. So we're going to have to make a figure to put the plot in. So we're going to make subplots. And then we're going to want to add our data points to it. So I'm going to add a trace. And using the graphic objects package from Plotly, we're going to make a 3D scatter plot because we have 3 variables which we are wanting to plot. So x is going to equal the Reynolds number, y is equal to the Schmidt number, and z is equal to the Sherwood number. We're going to want to use markers for that. And then we're going to make the size of the markers larger, that way we can better see. Alright, so here we go. We have our points plotted along the x, y, and z axis. We want something a little better though, because x, y, and z doesn't really tell us that much, and we also want to make a mesh for them. So we are going to make up some values, make values for our grid. So we're going to use the numpy's mesh grid function, and we're going to need linear spaced points based off of the values for our Reynolds and Schmidt numbers. So np.linspace using the Reynolds numbers bounds, and we're going to make 25 points. And then we're going to want to do the same but for the Schmidt number. Which is 0.6 to 2.5, and we're going to want another 25 points. I did something wrong here. Oh. There we go. Okay, so now we have our points, making pairs of points with our Reynolds number here, and this array is the Schmidt number. So we're going to want to store these in some variables. So we're just going to call them the Reynolds number but for the grid, and the Schmidt number but for the grid. Alright, and then we're going to need to also make one for our Sherwood number but for the grid. So we're going to be doing the same equation that we did before, but using our grid variables in order to make them. So we're going to have to make an exponential of the unknown, the first init, times the Reynolds number for the grid to the power of the second, times the Schmidt number for the grid to the power of the last point in the array. Alright, and so now we need to actually make some points in the 3D space for the grid to go on using the zip function. So for, we're just going to have to make new variables. We can't use x, y, or z, abc, or anything like that. We have to use I, J, and k, because we've already used them. Because we haven't used I, J, and k, I mean. So for I, J, k in zip, we are going to want to have I equal to Reynolds number for the grid, J to be the Schmidt number for the grid, and K to be the Sherwood number for the grid. Alright, and now we're going to add a trace for these. Add trace. And we're going to use another 3D scatter plot with x being equal to I, y being equal to j, and z equal to k. In the mode this time, we're going to use as lines because we're trying to make that mesh grid. Equal lines. I need and line. Don't make the line color white. That way we can actually see. And let's see if that works. Oh, that does work, but I want to see what it looks like, so we're just gonna have it show us what we just made. And I messed up my parentheses here, and I don't need that one there. And there we go. Okay, good. So we have that for our Reynolds number. Now we need it for our Schmidt number. So we're just gonna simply copy and paste, starting where we made the grid variables, and we're going to switch them around. And we're gonna change the variables around, or not the variables, but the limits, the bounds. And then that should make our proper mesh grid. There we go. So now we have the lines, the mesh grid, but we have this legend here that we want to get rid of, and we want to make we want to label our axes and make it more of a uniform shape. So what we're going to do is just fig.update layout. All right. We're going to set the width to 800 and the height to 800, just so it's a cube. And then we're going to want to turn the legend off. So show legend equal to false. That way it doesn't show it. And then we're going to want to change the labels on the axes. So we're going to make the x-axis title equal to the Reynolds number, the y-axis title equal to the Schmidt number, and the z-axis title equal to the Sherwood number. Oh, and I did something wrong. I just misspelled update layout. And there we have our graph with our mesh grid.